Hi Spring fans, welcome to another installment of Spring Tips. In this installment, we're going to look at a very interesting pattern which I was recently reminded of called hedging. Now, hedging is a pattern that makes it easy for clients that have a deadline or an SLA sort of driven sort of use case to achieve that use case by making multiple calls in concurrence and responding with the first request that returns. Basically, so if you make a call to a service and that service is going through a garbage collection pause, or it's down, or it's got some latency, or whatever whatever hiccup might be causing it to be in trouble, you make multiple calls and you hedge your bet that one of them will return in time by making multiple calls, so that you have one that will succeed, and that whatever ones. If the other ones come back, great, but if they don't, that's fine too. You can just discard them, right? You don't need them. This, of course, only works if you can make calls multiple times. They have to be idempotent, right? They have to be able to survive multiple calls without any undue sort of observed side effects. So it's a very interesting pattern. Now, this is one of those kinds of patterns that requires a service registry, right? There's a lot of things that we could do, and we talk about in a cloud native architecture. We talk about service registries a lot because there's a lot of patterns that go beyond what we can do with just regular DNS, right? DNS is useful, but it is not for a lot of use cases sufficient. So DNS tells me where something is supposed to live, not if it's alive, right? That difference is important. Knowing if a service is awake and alive and able to respond is very different from knowing, the location of that service. I need to be able to, in order to be able to do different kinds of load balancing, client-side load balancing, I want to be able to control that on the client. I want to be able to have more control over the routing from a client to a service, and I can control that on the client as well. So that's another use case where having the ability to talk to a service registry and then ask the service registry for any of a number of different services that are out there, and then being able to make the decision based on any kind of criteria or predicates, whatever, that can be very useful, especially if you have very particular load balancing kinds of use cases. For example, suppose you want to do multi-tenancy or data center awareness or these kinds of things, sharding, whatever it is. You can do this if you understand how many instances of a given service you have and their locations. Also, DNS has some limitations, and you can fairly easily get around them, but it is just one of those things that you have to remember to do. For example, DNS clients like Java will cache resolved IP addresses. So if you go to a DNS server and the DNS server gives you an IP address, the Java client will keep that and then route subsequent requests not to the DNS server but to the IP address. And so that means that the clients will end up unfairly dogpiling on the first IP address that's been resolved in that JVM. Next time you restart the JVM, it might re-resolve. Obviously, you can fix this by setting your DNS to have a time to live value of 0, and then the client will do the right thing. But these are the kinds of things you have to remember, and they're not exactly front and center. They're buried in, I think, what most of us would consider sort of arcane configuration parameters. So we don't want to have to deal with these kinds of things. And so in this pattern, hedging is just one of those things where it just really works well with a service registry, because you need the ability to ask something for 2 or 3 or n distinct instances of a given service. So what we're going to do is we're going to use a service registry, and it can be used you can use any service registry that Spring Cloud supports, right? So Spring Cloud's got the DiscoveryClient abstraction, and the DiscoveryClient abstraction gives you the ability to ask the question, what instances are there given a service ID? And there's an implementation for this interface supporting Cloud Foundry, for supporting Kubernetes, supporting Netflix's Eureka, Apache Zookeeper, HashiCorp Consul. I mean, probably more I'm forgetting. So we're going to go ahead and build a new service registry using the Spring initializer here called Eureka. We're just going to make it a Eureka server like so, and we'll hit generate, and we'll open that up in our IDE. There we are. And so we're going to say, open this up. I'm using my little command line script here, of course, as always, to open up the project. But you could use the wizard inside of IntelliJ if you like. Excuse me. A little sick. All right. So we're going to open this up. Alrighty. Application.properties, thank you. And you want the Eureka server application itself, good. enable Eureka server. Very good. And our job is just to configure this so it's listening in the standard place where we can expect to find it, A761. I want to tell it to not register itself and not to fetch the data from itself, basically. So that's it. Once I do that, that would normally be enough, but we're running on Java 11, and actually I'm not even sure if this will work. We'll try it, but we need Java 11. We're running on Java 11. I'm using Java 11. This works just fine on Java 8, of course, and probably 9 and 10, but in Java 11 they moved out some APIs that were part of Java EE. Those are no longer bundled in the core JDK, which is overall a great thing, TM, right? It allows the JDK team to move faster and so on. But in the meantime, that means that we have to, where appropriate, bundle those jars manually. And that's not a big deal. That's the nature of dependency management. For now, that's not being taken care of for us by Spring Cloud, but I suspect that would be fixed in no time. So for now, all I've done is I've added the JAXB APIs here, JAXB Core, JAXB Impla, the JavaX activation stuff. And again, this is all very nicely extracted out into a property, like so, JAXB.version. All right, replace all, very good. So there you go. So now it's just, yeah, I can change it one place, all right? Now let's go ahead and kick this off. Alrighty, so there it is. It's up and running. It's available for use, and we can confirm as much by visiting the service on its configured host and port, which of course in this case is localhost 8761. So there we are. No instances yet, nothing registered. So now let's go ahead and build a simple service. We're going to just build a brand new service, and this service is going to have the smarts that it needs to be able to register with that with the registry. So we're going to call this, imaginatively enough, service, and we're going to use the Eureka support, the Eureka client support. We're going to use Lombok and the reactive web support. Okay, so we're going to build an application. This is the other thing that's nice about this pattern is it lends itself to reactive programming, actually. So this is a great example where these two things really complement each other. They multiply each other. Okay, so we're going to go ahead and hit generate, and that'll give us another project here. Downloads UAO service.zip, and our service, I think, is going to be straightforward. We don't, we're not actually trying to test that we can write a service. What we're trying to test is that we can, make multiple hedged calls to that service. And so the service itself is pretty immaterial, right? It doesn't have to be particularly interesting. All we want to do is have something that will create an artificial delay that will then be able to sort of randomly prolong the lifetime of a request, and so we can see that one returns before the other. So let's do that here. Let's go to our service application, and what's the easiest thing we can do? I guess we want just an endpoint, a reactive endpoint, or not. We just need any endpoint. I suppose this part doesn't have to be reactive at all. So get mapping hi string greet. And what do we want to do? We want to have it's a REST controller, right? So REST controller. And we want this thing to be an object that will have a delay. And our delay will be we want to have a little bit of randomness here. So what we're going to do is we're going to say, give me the longest of two random numbers. Okay, and I guess we can, what do we want here? Let's see, void random. We want to have random. New random next long. Okay, and I'm going to multiply this times some number of seconds, so times 1,000 seconds. Okay, times seconds, and we're going to return a long. So there we are. Is that okay? That looks fairly straightforward to me. Okay, so I'm going to say give me the longest of two numbers of two random durations. So whichever of these two delays takes the longest, I want to use that one. And then I'm just going to artificially sleep, which is the least elegant thing ever, but it does the job here. And that of course requires an exception, so we'll add that to the method signature. And then finally, having done all that hard work, I'm going to say string message equals hello. Whoa, not Jello. Love Jello, but not hello, not Jello. Hello. After delay ms. Okay, and then we're just going to return that message. So that way we'll have the ability to see how long the service waited for us. Okay, or how long we had to wait for that service call. Okay, so there we go. We've got now a service. Is that enough? I think we need to, so I want to run this application multiple times, and so as a result, I'm going to make it distinct. I'm going to give it some distinct configuration so that I can run the application multiple times and not have it stomp on each, not have each instance stomp on each other on the same host. Again, this isn't such a big deal in different hosts, but it becomes more interesting in a demo scenario like this. So first, I'm going to say I want you to run on a different port, 0. And then second, I'm going to give it a name, spring application.name equals service. This is the name by which it'll register in the registry. I'm going to give it an ID, and the ID, I'll just derive service. I want this to be resolved once, so I'll extract that into a variable here. And I'm going to use a pseudo property, a very interesting property inside of Spring called random.int. And here, I'm going to provide a range, so 1 out of 9999, and then I'm going to use that to create a Eureka instance ID. Okay, there we are. So that's this will give me a random name. Each instance, each client that registers in the registry will have a different label. Basically, it's assigned to it, and we're going to establish that label once, so it's consistent across the lifetime of this service. Okay. We don't actually have to do anything else because by default, Eureka is running on the default port, and it's going to use the Spring Cloud DiscoveryClient abstraction implementation to talk to that. So, yeah, let's just go ahead and... Oh, we have to do one more thing. In IntelliJ, we have to turn off the single instance only. Hit apply, and go. So let's see. Hit OK. 1. Okay, take 2. Okay, and good measure, let's just do it a third time. And if we go to our registry, we see we have 3 instances of the service right here, right? That's where it says 3 instances. And they're called service 7115, service 3896, and service 7148. Okay, so now they're accessible, they're visible. If I were to point some other service to this node, to the service registry, I could programmatically ask for how many instances there are out there of this service, and I would get back 3 service instances. And that's what we're going to do. We're going to build a client now to talk to our service via the service registry. It's going to resolve instances through the service registry. Now this is also going to use, as before, our service registry support. So Eureka Discovery. We're going to use Lombok. We're going to use the Reactive Web Support actuator, just because that's good, clean cloud hygiene, right? And I think that's pretty much it. I can't imagine what else we would need. Got the Reactive Web, got Eureka, got the actuator, got the Lombok support, and Reactor gets brought in automatically, so we'll hit client, hit generate, and UAO client.zip. Okay, now, same thing as before, we need this application to start up, and it's going I suppose we should pick a different port just in case. There we go. Okay. And our application is going to be a REST API in itself that will make a reactive web client call to another node. And so we'll say this is going to be a class hedging REST controller. All right. And we'll say at REST controller. And let's think about this. We want to get the message, right? So we'll have a endpoint here that returns a string, greet. And in order to make this call, well, first of all, we want the client will make a call to hedge, like that. And then in order to make that call, we need a reactive web client. This is a HTTP client that's in Spring Framework 5 or later, and it's reactive, so it doesn't block the client thread if at all possible. And so we need to instantiate. We need to factory an instance of that. So we can create a web client bean here. Return web client.builder.build. All right. Now, this isn't in of itself enough. We need to actually configure a filter that does the work of doing the hedging. So let's see what the naive version without the hedging looks like. .get.uri /service/hi. Okay. And then we're going to say we're going to retrieve the data that comes back and just turn it into a payload of type class, string.class rather. So that would actually give us, assuming this was a valid host name, this would work. And some of you may know that you can even do, there's even a load balanced annotation in Spring Cloud. And the way that works is you say webclient.builder, and in this case, you don't actually build the builder yourself. Or the web client yourself, you use the builder, and then you continue customizing it, but basically Spring Cloud will auto-configure a builder instance that, is ready for you to build, as I'm doing in here, or to further customize. But in this case, because I have @load balanced, I've told Spring Cloud to create a web client builder for me, and to configure a load balancing filter, an exchange filter function that handles, it pre-processes every HTTP request that I make, and it's going to, in this case, extract out the host name. It's going to identify that. It's going to treat that as a service ID in the service registry, and it's going to talk to the service registry using the DiscoveryClient abstraction. So that is kind of what we want, but we want that hedging behavior. So this isn't exactly what we want. We want the same thing. So, keep that in mind. And what I'm going to show you today, you could extract out into such a filter. We could, create auto configuration that, at hedge or something like that. I don't know. But that's certainly an exercise for maybe the next video. Who knows, But in the meantime, we'll build it ourselves so we have the ability to customize it all. Okay. So there's this. And now we do need a filter, don't we? So I said that the meat of this work will be done in a filter, which I'm going to call the hedge exchange filter function. And this is going to implement the exchange filter function contract in Spring Framework 5. Okay, and job's fairly straightforward. We want to implement the filter method here. Filter is the only one that's required. The rest are actually default functions. So you can see it says default and then default apply, etc. We can do that because this API assumes Spring Framework 5, it assumes Java 8, and it assumes default methods. Okay, so we've got now a filter that is going to be given a chance to process the request, process it, and then forward it on to the next filter in the chain. If this looks anything like the servlet filter API, good. Now you should have a fairly good idea of what's happening here. We actually have a chain of different filters that are going to be put into play here. We want to use them to process this request, and we're going to do a lot of the same work that the load balancer exchange filter function does, the one with @load balance. So we're going to do a lot of that same work because we do, after all, need to resolve this via via the service registry. But we need to do so, and then given those choices, we need to pick the one that comes back first. So it's a different goal, isn't it? It's a little bit further. So our exchange filter function is going to depend on a discovery client, Spring Cloud DiscoveryClient, will depend upon a, what else do we need? I guess we need a load balancer client. This is the load balancer client in Spring Cloud. This is what's used to, ultimately this defaults to Ribbon, right? Ribbon is a client-side load balancer, also built by Netflix, but this load balancer client adapts it so that it doesn't only work with Netflix types and Netflix projects like Netflix Eureka. And I suppose we want some definition of, how many attempts we want to make, and then the max attempts, right? So let's say we want to make 3 calls, but it doesn't work, so we want to skip. We want to keep trying until max. Okay. Okay. So there we go. So those are our 3 variables. Our 4 parameters. Okay, those is constructor argument here, and of course you can imagine these would be configuration values or something like that, driven by configuration properties. For our purposes, we're going to say that we want the max attempts to be attempts times 2, okay? And the attempts themselves, I suppose this doesn't even need to be defined here. We can just make this simpler for now. You can parameterize things to your heart's content later, but let's just keep it a little simple, okay? So we're gonna use the load balancer client, we're gonna use the discovery client, we're gonna use the attempts, and then we do need to have some default configuration. So I think, and I want to have a separate constructor. Since I'm just using component scanning, I need to tell Spring Cloud how to resolve this dependency. And I think for this one, I'll just use a load balancer client and a discovery client, LBC DC, and we'll just assume that you gave us a default value there of, let's say 3, because that's what we've got running on our machine right now, isn't it? Okay, so that means, okay, good, so we've got that now. And now for the work, the actual hard work, and I use that with air quotes here because it's not such a big deal. What we're going to do is we're going to say, when the request comes in, we want to get the original URI, right? Original URI of the request coming in, java.net, and the request is, of course, on the URL itself. And then from there, we want to get the string service ID, I think, and that's going to be the original URI.getHost. And then from there, we want to get a collection, a list of service instances, services that match this service ID, and we do that using the discovery client. Get instances for the service ID. Okay, that's okay. Actually, we have enough space there. Good. And then from there, we want to count. So we want to say we want to launch a number of different calls at the same time. Okay, so we're going to need to store each of those launched ships, basically. We're going to launch a bunch of ships into the night, basically, and each ship will go out and make a request and then come back to us, and whatever comes back first, we'll keep. So new hash map, and you know what I just realized? Since we're gonna run this, and we're gonna make requests, we're only gonna get the first one that came back, so we're not gonna see how long the other ones took. So we need to actually announce that here in the service that I built a second ago. So let's go back to that service and make sure we launch, or we log out, this message. Okay. Goodbye. Goodbye. Okay, and we use Lombok here. Message. Turning. Alrighty, so there's our message. Okay, so that way we'll see it on the console. So we'll see what could have been the path not taken, so to speak. We don't need to run these right now. Let's just go back to our code and we'll run them in a second. Okay, so now we're going to have a map that stores all the different launched in-flight requests. And we're going to say, while the size of the map is less than this.attempts and the counter is less than this.maxAttempts, then we want to load balance by using the load balancer client, and we're going to choose from among the service IDs, and that'll give us back a service instance, and then from there we want to get the URI of that instance, lb.uri.toASCII-string, and then from there we want to make sure that we haven't already seen this one before. So if not, ships.contains key ASCII string. If it's not already there, then we're going to say ships dot. Actually, I suppose we could have just done that instead, huh? But that would require that we actually compute the result, which I don't want to do. So we're gonna avoid. I guess we could have done this actually. That would have been easier too. Yeah, let's try that. So let's do that instead. So instead, I'm going to say compute if absent, and it's going to be the ASCII string, and we're going to say if that string doesn't exist, then give us the key, and we'll use the key to arrive at the value that has to be stored there, which in this case is going to be a mono of client response. And so that is where we're going to actually have a call to actually make this request. Let's factor that out. Let's extract that into a method here, mono of client response, invoke, and we'll come back to this in a second. And what is that going to do? I guess that's going to say invoke. Okay, that looks fairly straightforward, doesn't it? So not bad. Okay. We need to actually parameterize that, don't we? So okay, so while that's happening, you know, we'll have when this is done, we'll have a bunch of maps with client responses in them, right? And we'll have a map with a bunch of client response monos of publishers. Now these are reactive. These types have not executed yet, right? That's the whole point of this, is that it hasn't executed yet. And the reason that's interesting is because they only get executed once they're subscribed to. They're inert. They're like the Java 8 Streams API. You have to activate them. You have to execute them. You have to subscribe to them, to drain them. Okay. I'm not sure why I need this yet. Maybe we'll leave it there. So you know, basically we can create as many of these as we want, but all we're defining is a pipeline, not the actual request over the wire. And we can, when we do make the request, because they're reactive, the scheduler can schedule these things concurrently, which is very convenient. Okay, so now for the request itself, for the invocation of the request, we need to have the service instance, I would think. That seems useful. So where's our instance? It's LB, and we want to have the original URI, and we want to have the request, and we want to have the next one in the chain. Okay, so let's change the signature to accommodate this. Service instance, okay. Client request. All right, now we're going to invoke that, and that will in turn require us to actually make the call. So how do we do that? Let's think about this. We've got the service instance, we've got the URI. So we just need to actually make the request, right? This code is more or less exactly what you would have found in the load balancing exchange filter function as well. So you know, we're going to do that. So we're going to say URI equals this.loadbalancerClient.reconstruct URI. So what this is going to do is it's just going to, given a service instance that we have chosen, and given the original URI, you know, the original URI said, you know, http://service, it's going to replace that with the IP that's in the service instance. The service instance has things like host and port and scheme and URI, and so it's just gonna process that URL for us very nicely. It's gonna build up a new URI, which is easy to do using JavaNet URI, because it's very easy to build APIs that way. Client request. This is going to be the new request, isn't it? So this will be the new request, and I'll say client request dot create request dot method, and what else do we want? Oh, we need the URL. Alrighty, and we'll say headers, and we're going to say what the header is in there. I guess all we're trying to do is to copy all the stuff from the old one into the new one, right? So headers dot add all headers, great. And I guess we'll do the same thing here for the cookies. C dot add all. Is that right? Yeah, that looks right. Oh, sorry, it's a request dot cookies and request dot headers. Okay. Call it H, make it a little easier to parse. Okay, so it's the header. So for each header H and each cookie C, for the config for that, we're going to add the thing from the requests itself, and then we'll have the attributes, request attributes, right? So not attributes. I'm not sure why I keep auto completing on the ones that are the singular form of those things. So a dot put all, and this is going to be the request dot attributes. And what else do we need? I'm not sure. I guess that's it. Body will be request dot body. Okay, and that looks like that's a fairly good clone of the request. Hopefully I didn't miss anything important, but we'll see. I have a feeling. So now finally having done that, let's invoke the next downstream thing in the chain. Exchange new request. So the downstream part of the filter will see the new body, the new request. This is a very common pattern even in the filter, even in the Java Servlet Filter API thing. But of course, this is the client side, not the server side. So it works the same way, but it is by no means the same. It is asynchronous and non-blocking and reactive. There is no servlet API involved here at all. And of course, it's on the client, not the server. So what I'm going to do is, finally, I'm going to say that I'm going to announce every single launched ship. I'm going to do so by logging it out, just so we have some sort of ability to look at what's happening on the client and on the server. We'll say this.log, or I guess just log. And then we'll say launching new request.uri. All right. Okay, that looks okay. That looks fairly straightforward, I guess. So here, finally, is where the metal rubber meets the road, right? So we need to say flux dot first, very convenient, given a publisher of things, subscribe to all of them, and the first one that completes, we return with, right? So that's the magic of the algorithm, if you will. That's the hard part, right? And then we're just going to say, give me either the first one or an empty mono. Very, very simple. Couldn't get simpler. Okay, and so we're using the map really just to make sure that we don't have any duplicates. That's the only reason we use the map. But then we throw away the keys after we've done the deduping to get the list or the collection of publishers, the set of publishers. And then we use that to figure out which one comes back first. Okay, so fairly straightforward, right? Not a big deal. Not a lot of code. I mean, there's a fair amount of code, but I think variables, constructor. Another constructor, so really not a lot of code. I mean, if you look at it, this is most of the requests. That's 62 to 77, so 15, and then 85 to 96, so 11, right? So not a lot of code, right? Not a lot of code at all. I guess I didn't need this. I wonder what I thought I was going to do with that. I wonder if that's important. I must have had some insight. I mean, we were writing this code together, my friends. I don't remember why I wrote that. What do you? Feels like that could be useful. Oh, you know what we could have done with that? Let's leave that here. Let's make sure. You don't have to do this, But let's say that we want to make sure that there are instances of this service. Otherwise, we're going to be, we'll never get what we want, right? So there must be at least this dot attempts instances of the service. Service ID. Okay. So there's our, we're just going to make sure that we, before we try load balancing and all that stuff, that if you ask us to call 3 different instances, that there are 3 different instances, because it's, what's going to happen is in the next line or the next few lines, we're going to keep a count and we're going to say, okay, while the map that we've built that accumulates all the different in-flight requests is being built, it's being built against unique URLs. If those unique URLs, if we try and add something that is already that's already been seen, then it's gonna it's it'll try again, won't it? It'll try and choose another one, and we don't want that. So that's not good. The other thing that occurs to me is that in this case we're actually using the load balancer. So I'm using the load balancer and I'm saying, using the load balancer algorithm that we've got, pick one from among the configured instances. If you don't care about that load balancer, you could just throw the first 3 service instances from this collection in the map, right? As long as this list is greater than or equal to the attempts count, you could just throw the instances that are in there that are before or at the budget that we've got, the quota that we want. You could throw those in the map and just ignoring load balancing, just pick any of them, right? But you wouldn't be able to take advantage of the load balancer algorithms, right? And you may not care, and it would have the benefit of being one call. If it takes one call to get all 3 of these, whereas conceivably this load balancer client might have calls to other things that have metadata that you want to interrogate. Okay, so that's a discussion. Maybe you performance analyze that. I leave that to you as an exercise. Okay, so we need to do our final thing here, which is teach our client about it. EFF. Okay. Filter, EFF. Very good. All right, let's see what happens. Do we have an endpoint that we can use to test this? We do. Hedge. We got the client. We're making a call to /service. Okay. And we should actually start up that service actually now. So where's our service? Over here. Go. One, 2. Oh, I was ambiguous. I have 2 constructors. Spring doesn't know which one to go with. Here's where I use the auto-wired annotation. It removes the ambiguity. Oh, I just restarted the wrong one. That was the Eureka service. Let me restart it. Okay, so that's the client. Eureka service is spinning up and down. Here's our service. Restart. I'm not sure which ones were restarted and which ones weren't. Okay, that's 1. It seems okay. Okay, there's 3 of them. Alrighty, so it's going to try all 3 in this case. Obviously, if we did 4, it would hopefully just try 3, not all 4. But it's nice to know that it has the ability to try it if it needs to. And now we want to say curl HTTP localhost 8081. Right, what did I say? Here's the service, client application, which server port is it? This is on port. That's the service. We want the client. Here, 8081, right, good. And the endpoint is called Hedge. Okay, what did we do wrong? Failed to handle this, launching it to that. Well, that's interesting. Do I have some sort of weird DNS issue that's because of my my hotel Wi-Fi? Ha, looks like I do. What happened there? It couldn't resolve, so of course that didn't work. Okay, so let's see what Eureka is saying. Eureka is saying it's got one client and 3 service instances, and the services and the client, for example, is unknown. What's the status of? Okay, well that's interesting. Oh, the value is negative, so it threw an exception. That's the issue. Aha. So, what happened here? We got what just happened? Is it really negative? I guess that's, I mean, that seems, I didn't know this would do negatives. Let's see, next int seconds times, there you go, that looks like it's more reasonable. So that's, okay, let's kill this and that. One, 2, and 3. All right. So the old ones are gone, but there's 3 brand new ones here. Good. So the service is responding that's not localhost, but it's still an IP address that I have on my local machine that are resolvable. The client will, I think, see these 3. Let's hope. Close that. Close this. So now there must be 3 instances of the service up and running. Right now, my client, the heartbeat event for the client hasn't percolated back yet. Right? So, I suppose we could just force its hand. It usually takes 30 seconds for it to reestablish a connection with the service registry and then have a heartbeat event that percolates back to the client, where it then refreshes its materialized view of the service. But since we don't have that kind of time, and I don't want to bother with configuration right now, we're restarting, starting from 0. Take 2. Okay. So, hello after 3 seconds, or 3,000 milliseconds, or 3 seconds, right? Let's see what our console shows. Here's the client. Here's the Eureka. Here's a service. This is after 3 milliseconds. After 4 milliseconds. After 4 milliseconds. Okay? Let's try it again. So, that one took 3 milliseconds. This one took 2 milliseconds. Wait, no, sorry, let me try that again. 2, 3. So one of those 2s will have 1, right? It'll have returned. And it says after 2 milliseconds. So there you go. The first one that returns is the one that we're getting back, and we are discarding the others. But at least if we have a deadline here, if we absolutely must return on time, then this is a very useful technique. Obviously, you can mix and match this technique with other things that are built into the reactive stack. For example, it is trivial to specify a timeout on these requests, because even if they don't return it, even if they're no longer in time to serve the client request, you still don't want them out there just off in the wilderness, just waiting for something that's never going to happen. You should specify an aggressive client-side timeout so as to free up the resources represented by that request on the client. So you can specify timeouts. You can also do retries, right? The reactive, if you're using the Reactor project, which is the thing that underpins the Reactive WebClient or the Reactive support in Spring Framework 5, there's support for doing retries, right? I mean, there's all sorts of things that you can do here, but the speed benefits we get here are through parallelism, right? Those other things ensure that your system cleans up after itself, that you don't waste resources, which is valuable. But in order to meet your deadline, we fan out, make as many calls as we can in concurrence, and then return immediately. And the benefit of that, of course, is that here in the client application, in the client, we're just making a call. We've got a publisher that has one value in it, which is our string message. We don't know that this is in turn going to result in 3 other calls. We don't care, right? Our code is much simpler logically because we just know that we get the first one that returns, and then we can actually build multiple calls using the same web client. I can call service A, service B, and service C, and I can use things like flux.zip, right? I can say call A and B, and the result of that is it's a flux. It's a publisher that has a tuple whose first operand T1 is the type of the generic parameter of A, the flux of A. And then type 2, T2, is the type of the generic parameter of the flux of B, right? So you can do some very interesting things where you call 2 different services and then compose the results in a stream. You pull one from the left side, pull one from the right side, pull one from the left side, etc., like a zipper. That's why it's called zip. You can do all sorts of interesting things like that. And this is concurrent, and it works the way you'd expect it to. It's just you can call 3 services too. Obviously, I'm just talking about some very simple cases here, but that code, each one of those could in turn result in 3 calls. Now, do you have to worry about the scheduling? No. As long as you're not blocking anywhere, then the scheduler on the default configuration should just be fine. You can, of course, you can customize the scheduler object that's used in Reactor to change that behavior. I want to thank John Schneider for reminding me of this pattern. John Schneider, of course, is the lead of Micrometer. He's a real smart guy. You look at the code for Micrometer, and you can see this is we are very lucky to have people like him on the Spring Cloud team, helping build the most robust framework for microservices. All right, thank you, my friends, and with that, we'll see you next time.